press the bell icon on the YouTube app and never miss another update.
Hello students, we continue the next problem in exercise 1.1. So up to second domain we finish up. Third domain, it is very important. Write the following sets in roster form. Roster form means tabular form. Yes, na, both are same. Roster form also nothing but tabular form. The first question, he has given in set builder form. Rule method he has given set A x such that x is an integer. X is an integer and x greater than -3 less than 7. X greater than -3. This is nothing but a rule method, set builder method. So using this condition we build a set. Yes, na, using this condition. See, observe here x. So for such that, so they assign a rule for the given alphabet. What is the rule? It is an integer. Correct, na? It is an integer and the integer must be greater than -3, less than 7. The integers in that collections, what we write in that collection, it must be greater than -3, less than 7. So we write A. Okay, set of all integers. So -2, -1. So we write the comma to differentiate two elements. We write the comma. Then after that 0, 1, roster form means what? We write all the elements within a pair of curly brackets. Yes, na? What I explained in the previous class. We write all the elements within a pair of curly brackets. So -2 is over. -1, 0, 1, 2, 3, 4, 5, 6. Yes, this is nothing but roster form. Understand? Second problem. Set B x such that x is a natural number. X is a natural number less than 6. X such that x is a natural number less than 6. We build a natural number less than 6. So write the answer. You also write the answer. B is equal to, okay, natural number less than 6. 1, 2, 3, 4, 5. 6 we have read? No. Less than 6 he wants. 1, 2, 3, 4, 5. Understand? Third problem. C. X such that x is a 2-digit natural number. 2-digit natural number such that, right below, such that the sum of its digits is 8. If we write those two numbers, those two digit number, if you add those two digits, it is equal to 8. Okay. So and those two numbers are what? Natural numbers. You also write it. So if I write 1, then 1 7, two digit number. If you add 1 plus 7, it is equal to 8. If I take 2, 2 6, 2 plus 6 means 26, 17, 26, 35, correct na? 35, 44, 4 plus 4 is 8, 53, correct? 53, next 62, 6 plus 2, next 71, correct? 71. If you add those two numbers in a two digit number, its sum is equal to what? 8. So this is the set C. Understand? Next problem. Fourth one. E is equal to the set of all letters in the word trigonometry. In the word trigonometry. So we discussed in the previous class, we take two words, one is English, another one is communication. Yes. So E is equal to, very important, T is repeated 2 times. I explained in the previous class, repetition of the digit is not allowed. So we write only one time. R is repeated 2 times, but we write only one time. T, R is over, T is over, R is over, I is over, okay na, G over, O over, N over, M over, E, and what left? R is also Y. Observe carefully, T is over, R is also over, I over, G, O, N, M, E, T and R also over, Y. Correct? So here very important, in that collection, why given this problem, he say one concept. In the collection of sets, repetition of the digits is not allowed. Repetition of the digits is not allowed. Next question. Fifth one. F is equal to the set of all letters in the word better. In the word better. See, observe here, F is equal to B single time, comma. E is repeated 2 times, but we write only 1 times. T is repeated 2 times, but we write only 1 times. What left? R. Correct? One more question. Sixth question. D is equal to X such that X is a prime number. A prime number which is divisor of 60, which is divisor X such that X is a prime number which is a divisor of 60. So we write all the collection. Prime number 2, no doubt, 2D is a divisor of 60. 3, no doubt, 3 is a divisor of 60. 5 is a divisor of 60. Yes, 5 is a divisor of 60. 7, no. 9, no. Enough. 2, 3, 5. Yes, 2 is a divisor of 60. 3 is a divisor of 60. 5 is a divisor of 60. Prime numbers are 7. 7 is not a divisor of 60. Then 11 is not a divisor of 60. 13 is not a divisor of 60. The elements are 2, 3, 5. Yes, understand? Fourth main. Third main is over in 1.1 exercise. So we see the fourth main. Fourth main, what we ask, write the following sets in the set builder forum. Set builder forum. Under that, the first question. So we write A. Okay, A is equal to 3, 6, 9, 12. A is equal to 3, 6, 9, 12. So he has given in what? Tabular form. We have to write in set builder form. Correct na? He has given in tabular form. Means he write all the collection of the elements within a pair of curly brackets. What we do? We write in what? Set builder form. So for that, A is equal to. So I explained the previous class how to write the set builder. We write a alphabet X such that. Observe the carefully. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. X is equal to 3n. Correct now? In that collection, it is nothing but a multiple of 3. N belongs to n, natural numbers. Correct? N belongs to n. And very important, it contains only 4 elements. N is less than or equal to 4. Means greater than or equal to 1. N is greater than or equal to 1, less than or equal to 4. So observe here, we assign a rule for the given problem. So this is nothing but what? A set builder form. Understand? Next question, second question. B we write. B is equal to 2, 4, 8, 16, 32. 2, 4, 8, 16, 32. So B is equal to, same thing, X, such that X is equal to. Observe here, 2 to the power 1. 4 we can written as 2 square, 8 we written as 2 cube, 16 we written as 2 power 4, 32 we written as 2 to the power 5. So 2 to the power n. N belongs to n and n must be greater than or equal to 1, less than or equal to 5. N must be greater than or equal to 1, less than or equal to 5. We write in the set builder form. This is the tabular form and this is a set builder form. One more problem. Third problem. 5, 25, 125, 625. I think you have to write this. We can return as this set we represented as C. C is equal to 5, 25, 125, 625. Same problem. C is equal to, you also write it x such that x is equal to what? 5 to the power n. N belongs to n natural numbers and n is greater than or equal to 1, 1, 2, 3, 4, less than or equal to 4. Correct now? N is greater than or equal to 1, less than or equal to what? 4. 5 power 1, 5 power 2, 5 power 3, 5 power 4. Next, one more problem. Fourth problem. 2, 4, 6, dash. He is given. Very interesting. So this we can return as D set. D is equal to, observe here, D is equal to 2, 4, 6, dash. So we write in rule method D x such that x is equal to 2n. Multiple of 2 na? 2 1s are 2, 2 2s are 2, so 2 2s are 4, 2 3s are 6, 2 4s are 8, multiple of 2 power n, and n belongs to n. Because he has not end, it goes on. Here, next he write 8, next he write 10, 12, 14, 16, like that. That's why I write n belongs to n. X is equal to x such that x is equal to 2n and n belongs to n. Or else we write one more method. X such that x is an even natural number or x such that x is an even natural numbers. X such that x is an what? Even natural numbers. Even natural numbers. Understand? This is nothing but set builder method. So I think one more problem is there. One more problem in fourth line. The D is over now. Fifth question that we return as E. E is equal to 1, 4, 9 up to 100. Endpoints are given. E is equal to, observe here, 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 10 square. 10 square is how much? 100. So we can write it as x such that what we do here? N square. X such that, x is equal to n square. If I write 1 square. If I write 2 square is 4. If I write 3 square is 9. If I write 4 square is 16, n square such that. And n belongs to n. And n is greater than or equal to 1, less than or equal to 10. N is greater than or equal to 1, greater than or equal to 1, what? Less than or equal to what? 10. So this completes what? The fourth line. Fifth line, list all the elements of the following sets. All the elements of the following sets. First question. A is equal to x such that x is an odd natural number. So list all the elements x such that x is an odd natural number. Solution is odd natural numbers are 1, 3, 5, 7, 9, 11, etc. Correct na? Second problem. D. X such that x is an integer x greater than minus 1 by 2 less than 9 by 2. X is an integer x greater than minus 1 by 2 less than 9 by 2. B is equal to, so 0, 1, 2, 3, 4. Correct na? 0, 1, 2, 3, 4. Third problem, C. C is equal to x such that x is an integer x square less than or equal to 4. X such that x is an integer and x square less than or equal to 4. We write 2 square is 4. 2, 1 square, that is also less than 4. 0 square, that is also less than 4. 3 square greater than 4. Minus 1 square less than 4. Minus 2 square less than 4. Minus 3 square greater than 4. These are the elements. Fourth line. D is equal to x such that x is a letter in the word loyal. X is a letter in the word loyal. So that means D is equal to, L is repeated 2 times, we write only 1 times, L comma O comma Y comma A. Correct na? L O Y A. Next, fifth question. Fifth one. X such that x is a month. X is a month of a year not having 31 days. That is, I left to you very simple question. Not having 31 days. What are those? You write it. So this completes exercise 1.1. This completes exercise 1.1. Okay. Next one. Empty set. Next concept. The empty set. That means what? Empty set means a set does not contains any elements. The collection of elements are not present. The set contains the elements are 0. It does not contains any elements. Any elements are called what? Empty set. Empty set means a collection of elements are not present. it does not, otherwise in another way we have to say it does not contains any elements. So I given an example. For example, I write in the rule method a x such that x is a natural number, x is a natural number such that right here x greater than 1 less than 2. Very important. X such that x is a natural number such that x must be greater than 1 and less than 2. In that collections have no elements. Greater than 1 less than 2, there is no natural numbers. Yes, na? There is no natural number. In that collection it is an empty. It has no elements. Then such type of sets are called what? Empty set. Empty set means it does not any elements. It does not contains any elements. The representation of empty sets like this are we write within a pair of curly brackets. Within a pair of curly brackets. These two are the methods to representing empty set. See, the word say empty means in that collection there is no elements. In that collection there is no element. Such type of sets are called what? Empty set. One best example, x is a natural number such that x must be greater than 1 less than 2 means we have to write the natural numbers in between 1 and 2. We have to write the natural numbers in between 1 and 2. There is no collections. Correct na? There is no collection. That's why so the given set is an empty set. Representation of empty set are the two methods. This method or this method. Clear? So empty set is over. So if you want a proper definition, a set which does not contains any element. If you want the definition, I can explain simple method. A set which does not contain any element. A set which does not contain any element are called empty set. Next line. Empty set are denoted by. This is what I explain in a simple manner. This is what the definition of the empty set. So it may ask in 1 mark questions. Define empty set. That's why I write on a set which does not contain any element are called what? Empty set. Empty sets are denoted by using these two symbols. If you want an example, so write a is equal to write an integer. Write an integer such that the number is greater than 1 and right here less than 0. Write an integer. This is another example. Okay, na? Write an integer such that the number is greater than 1, less than 0, or else the number is greater than 0 sorry, less than. In that collection we have to write, but here the number is greater than 0, less than 1. That is x such that x is equal to I. I indicates what? Integer, and x is less than 1, greater than 0. X is less than 1, greater than 0. In that collection there is no elements. In between 0 to 1, it has no elements. In between 0 to 1, it has no elements. That's why this collection we call it as what? Empty set. This collection we call it as empty set. The number greater than 0, less than 1. The number greater than 0, less than 1, in this collection it has no elements. That's why this set we call it as empty set. Understand? Empty set means a set which does not contain any element. A set which does not contain what? Any element. Clear? Okay. Next one. Next concept, finite set and infinite set. Very important. Finite set and infinite set. First we define finite set in a simple manner. If countable number of elements are present, countable number of elements are present. So I write one example. A is equal to, it contains English alphabet letter, 5 English alphabet letters, A, B, C, D. One more I write the example. B is equal to empty set. B is equal to empty set. One more I write the example. C is equal to natural numbers. 1, 2, 3, 4, 5, 6, 7, natural numbers. Observe these 3 examples very carefully. Here 1, 2, 3, 5. 5 elements are present. Correct na? 5 elements are present. Correct? 5 elements are present. In the B set, 0 elements. 0 elements. Here 5 elements are present. In the B set, 0 elements. What about in the C set? Is it countable? Uncountable elements are present. Correct na? Uncountable elements are present. Here it is in these two sets. In these two sets, what? Countable elements are present. In these two sets, what? Countable elements. We have to count. Here it is 5, here it is 0, but here it is not possible to count. Yes, now uncountable elements are present. In these two sets, countable elements are present. So these two sets are called finite sets, and the set C we call it as what? The infinite set. A and B are finite set. So definition. Now I explain the definition. Finite set means a set which is empty. Firstly, a set which is empty, that is also a finite set, or definite number of elements. Definite means we have to count. The elements are 5, the elements are 6, the elements are 7, like that. A set which is, right here, a set which is empty, a set which is empty or definite definite number of elements, definite number of elements, a set which is empty or definite number of elements present are called what? Finite set, are called finite set. If suppose he may ask in the examination 1 mark question, define finite set, a set which is empty, empty is also finite set, a set which is empty or definite number of elements are present, definite number of elements are present is called what? Empty set. If uncountable number of elements are present is called infinite set. If uncountable means we are, it is not possible to count. For that what we write? We write dash representing the infinite set. This is the representing the infinite set. What we do? We write dash. That indicates, so end point is not, end element is not given. That's why uncountable elements are present. Okay na? Uncountable elements are present. That's why this set we call it as infinite set. Once again I explain, finite set means a set which is empty or definite number of elements are present are called what? Finite set. Infinite set means uncountable elements are present, uncountable elements are present are called what? Infinite set. Clear? So for that one more I write the example. This is because this is very important concept. So I write set A is equal to vowels. Five vowels, English alphabet vowels. B is equal to set of integers. So that is 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4. Is it enough? It is no. Dash. Here it is, how many elements are present? 5 elements. We count it, directly we count it, na? 5 elements are present. Then this set, we call it as what? Finite set. This set, we call it as what? Finite set. Here it is, uncountable elements are present. Here it is not possible to what? Count. That's why this set, we call it as infinite set. If countable elements are present, we call it as finite set. If uncountable elements are present, we call it as what? Infinite set. Understand? This is very important. Once again, I define the definition for finite. A set which is empty or definite number of elements are present, then that we call it as finite set. Otherwise, it is infinite set. Otherwise, it is infinite set. Is it clear? Okay. Next concept. Equal sets. Very important. Equal sets. For that, what I do? I write 2 sets. A is equal to 1, 2, 3, 4, 5. Set of first 5 natural numbers. Then I write a B set also. 3, 4, 5, 2, 1. Observe carefully those 2 sets. A elements are 1, 2, 3, 4, 5. B elements are 3, 4, 5, 2, 1. That means all elements present in A, all elements Not only 1, 2, 3, all elements. This is very important. All elements present in A, 1, 2, 3, 4, 5, are also present in B. Correct now? Observe here. 1 is present, 2 is present, 3 is present, 4 is present, 5 is present. All elements present in A are also present in B. And observe B elements. All elements present in B. 3 is present, 4 is present, 5 is present, 2 is present, 1 is present, are also present in A. All elements, first condition, all elements present in A are also present in B. Second condition, all elements present in B are also present in A. If these two conditions satisfies, then we say that set A is equal to set B. If two sets, definition, if two sets A and B are said to be equal, very important, said to be equal. If two sets A and B are said to be equal, then set of all elements present in A, then very important, set of all elements present in A are also present in B, and set of all elements present in B are also present in A. Then we say that A is equal to B. Very important. Suppose if I write one more element here, it is 0. For the same example, all elements present in A are also present in B. Observe here, all elements present in A are also present in B. All elements present in B are not present in A. Which one is 0? 0 is not present in A. That's why A is not equal to B. That's why these two very important conditions. If I strike out 0, all elements present in B are also. Observe difference. All elements present in B are also present in A. Then we say that what? A is equal to B. Two sets, very important. Two sets are said to be equal. In another way, number of elements in A is equal to number of elements B. Here it is 5 elements. Here it is also 5 elements. Correct now? This is first condition. One more condition. If two sets are said to be equal, all elements present in A are also present in B, and all elements present in B are also present in A. If these two conditions satisfies, we say that A and B are said to be equal. Clear? So these are the three concepts. First one is empty set. Empty set means a set which does not contains any elements. A set which does not contains any elements. So then that set we call it as empty set. One more is finite. A set which is empty or definite number of elements are present, we call it as finite set. Otherwise it is an infinite set. The last one concept, equal sets. Equal sets means If A is equal to B, if two sets A is equal to B, all elements present in A are also present in B, and all elements present in B are also present in A. If this condition satisfies, then we say that A is equal to B. Okay, we solve exercise 1.2. So exercise 1.2, first line, which of the following are examples of the null set? First question, under that first question, set of odd natural numbers divisible by 2. Set of all odd natural numbers. Odd natural numbers are 1, 3, 5, 7. These are all not divisible by 2. Correct now? These are all not divisible by 2. So that implies, so this I can write as A set. A is equal to empty. This is an example for empty set. Correct now? So no elements. Second example. Set of E1 prime numbers. Yes. So this I rated as B is equal to E1 prime number is there, one element, it is 2. That's why it is not an what? Empty set. Correct now? Not an empty set, because one element is present. Empty set means no element present, only one element is present. Third question. X such that X is a natural numbers X less than 5 and X greater than 7. X less than 5 and, so if you write any natural number, say it is 1 is less than 5, no doubt, and means it's the given number satisfies both the condition. Okay na? Not only one condition, here he has given and. So the given number satisfies both the condition. 1 is less than 5, but 1 is less than 5, correct? But 1 is not greater than 7. If I write 8 is greater than 7, no doubt, but 8 is not less than 5. That's why this set, which one I call as C is an empty set. This one is an what? Empty set. Correct now? This set we call it as what? Empty set. Fourth question. Fourth one, in the first mind, y such that y is a point common to any parallel lines. Why such that y is a common point? So if I write two parallel lines, these are all the points. This one is L1 and this one is L2. So there is no common points. Yes, no. So the set C is nothing but empty. So no doubt this is also an example for what? It has no elements. There is no common point. There is no what? Common point for any two parallel lines. There is no common point for any two parallel lines. That's why it is an empty set. So this is also an example for what? Empty sets. Okay now. So here we stop. We continue the remaining problems in exercise 1.2 in next class. Thank you.